Hi, good morning, everybody. In case you haven't been checking your email or you haven't been keeping up with announcements on Blackboard, last night I posted that Dr. White is a YouTube star. And I have my own YouTube channel, CHEMI, don't forget the I, 1105. You notice here's a link. If you come over to Blackboard, you'll see after syllabus, it says Dr. White's CHEMI 1105 YouTube channel. Click on that, click on the link. And you'll see I'm a YouTube star. I already got 4 views per, so I'm on my way to stardom. Not really, but I'll be working on getting everything posted up to speed. These are the last 2 lectures. Just so you know, I finally mastered the software. Now it takes me to edit that about 20-25 minutes. And then for my computer to process it, the video part, is about an hour, 45 minutes. And then to upload it and have YouTube process it, that's another about an hour and 15 minutes. So my actual time is about 25 minutes, but it's about almost 3 hours per video to upload. Luckily I have more than one computer. And this will be here all semester. It's not meant to replace coming to lecture, but a number of you said it will help, so check it out. Also, let me remind you, this Wednesday will be test number 2. As I mentioned, I think Friday, test number 2 will have 9 pages, multiple choice, but some questions have multiple parts. It covers chemical, excuse me, I'm getting all choked up over being a YouTube star. But anyways, it will cover chemical bonds and related topics, 50 points, mole and mole-related topics, such as balancing chemical equations, 55, it adds up to 105, so there's 5, 5, plus 5 bonus points. And as always, every question on my test, I've covered the concept in class, in lecture, at least twice, probably more times. And that's a bit, that's here. Also, if you look to lectures, you'll see I've posted test number 2, important information. This will be given to you. You can open it up on your own leisure. It has what a mole is, also the 3-part stuff on chemical bonds that you have to know yourself. And as promised, I'd like to go through test number 2 review, and then I'll do some practice problems from the gram-to-gram practice problem set, which I think will help you. And then if we have time, we'll get back to gases. All right, everything you see up here is on Blackboard. You can download if you want to go ahead and copy it, feel free to. All right, first of all, we'll talk, you should know how to do Lewis structures. Lewis structures of elements, you put down the element symbol, you look up the valence electrons, look at the top of the column of the periodic table, you'll be given one. Let's see if I have one. Nope, not today. But anyways, I think I posted one on, just like you see on the test, on in Blackboard. And 1 dot per side per valence electron, and you don't double up until each side has 1 electron, valence electron. And then chemical bonds. There are two types, ionic and covalent. You should know the definition for a chemical bond. For ionic, it's transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. For a covalent bond, it's the sharing of one or more pairs of electrons between atoms. In case you're not familiar, pair means two. You should know these definitions. For those who came in late, you can check and you can see it on Blackboard. I now have a link to my YouTube channel with videos of this course. Also, a quick thing, not more people are here. If you're, don't raise your hand, if you're a blue card student, you know who you are, please see me right after class today. I'll never ask on a test, but it's important to understand the octet rule, and that is in compound formation, forming chemical bonds. Atoms of elements lose, gain, or share electrons to get 8 valence electrons, and that makes it stable. And one way to become stable is to form ion. And a positive ion is formed when an element loses one or more electrons. A negative ion is formed when an element gains one or more electrons. Now, elements lose or gain electrons that have the same number of valence electrons as the nearest noble gas. Elements never lose protons. And I went through, when you form an ion, I went through in class and also problem sets that you should go back and review if you're not familiar with this, that you have an element, you look what's the nearest noble gas, then that element will want to have the same number of electrons. You have the electrons, the number of protons it has. Remember, protons and electrons are the atomic number on a periodic table. And then add it up, and you'll see what ion is for. And you show the ion by having the chemical symbol and the charge, which is superscript right. Now, an important thing, I'll never ask on a test, but you should know, all molecules have a net zero charge. Therefore, if I ask you to write the ionic formulas from ionic charges, remember, you can't change the charge, but you can change how many of that element are in a molecule. And as an example, you have a calcium +2 and a chloride -1. What would be the chemical formula? Well, calcium is a +2, chloride is a -1. Well, that doesn't add up to 0, but if you have 2 of them, it does. Therefore, the formula calcium chloride is CaCl2. Remember, come this winter, this is the molecule, those little white pellets you throw on your sidewalk when it's super cold and it's got ice on it, and rock salt, sodium chloride, won't melt ice at that temperature. Next, I talked about covalent bonds, and there are 3 types. I feel class participation coming on. Everybody together. It's Monday, you should be happy, the sun's out, no snow, no ice. What's the first type of chemical bond? Everyone?
Single bond.
Thank you. Second one?
Double bond.
Last one?
Triple bond.
All right. So you should know, single bond, 1 pair of electrons. I won't even cheat and look. That was an awful joke. And I cheated. I looked. Double bond, 2 pairs, and triple bond, 3 pairs. You should know that. And then I went through how to do Lewis structures for covalent molecules. You want to have an octet around each element. The exception is hydrogen. Hydrogen's octet is 2. And as I did in class, but I'll do again, I asked you to draw the, and we did a lab too, or also, if I asked to draw the Lewis structure of water, hydrogen 1 valence electron, oxygen 6 valence electrons. The only way this is going to work is oxygen in the middle, Each oxygen has 6 valence electrons. Each hydrogen has 1. And lo and behold, that's the Lewis structure. And remember, except for hydrogen, all elements have an octet. And if we look at this, we say, oh look, hydrogen 2, its octet is 2. I can use my other magic chemistry hand. Hydrogen 2, and now the grand finale. Oxygen 2, 4, 6, 8, it's got its octet, and that's how you do it. Now, one of the things I mentioned, and let me review again, if you look at the periodic table, elements, the alkali metals, hydrogen is not, and the alkaline earth metals always form an ion. They never form a covalent bond, and therefore, if I were to ask you to write the chemical structure for potassium hydroxide, also known as potash, the old chemical name, and immediately you should know potassium forms a +1, and you can figure it out, but you can remember too, the alkali metal are always +1, the alkaline earth are +2 cations, and then oxygen remember, potassium does have 1 valence electron, but it likes to give it up like that. It says, here, take my valence electron. Whether you want it or not, I'm going to give it to you. Oxygen has 6 valence electrons. Hydrogen has 1. Remember, look to the top, not in this periodic table, but the one I'll give you to see that. And now we look, hydrogen has its 2 valence electrons. Its octet is really 2. Oh, wait, oxygen only has 7? No. Where did this electron go? It went over here. And that's the Lewis structure. Remember, alkali metals and alkaline earth metals always form ionic bonds, never covalent. Next, I talked about chemical equations. This is how we show a reaction. And you should know that the base of the arrow, A and B, are the reactants. Sometimes in class, like often, I'll call them starting materials, but they're called reactants. At the head of the arrow, C is the product, when anything else would be the products. Now, when we have a chemical equation, it should be balanced. And balanced means you have the same number of atoms and type of atoms on each side of the arrow. Now here, if I take hydrogen and oxygen gas and react them, notice on the reactants, base of the arrow, I have 2 oxygen. On the product, head of the arrow, I have 1, so this is not balanced. How do you do that? You can't change the formula, but you can change what's called the coefficient number in front. And here, if I do this, I have 2 oxygen, 2 oxygen. 2 times 2 is 4 hydrogen. And how do I get 4 here? 4 hydrogen. That's how you balance it. And I like to check 4 hydrogen, 4 hydrogen, 2 oxygen, 2 oxygen. And the answer is 6 oxygen. We did it. I did it, and hopefully you can do it. Now, when you balance equations, you can only change the coefficient. My advice to you, this one is not the case, but when you have a number of elements, leave oxygen and hydrogen last. That will make your life a lot easier. as a special gift to you, not gift, but I can tell you on test 2, there'll be 4 balanced chemical equation questions. On my test, it will never be true, the answer, it's already balanced. If I ask you to balance an equation, you're going to have to balance it. All right, and remember the even-odd trick, which I taught you. If you have one side odd, one side even of an atom, multiply them together, and get each side to be that number. And we did examples of this in the problem set in our lab. All right, next, I talked about the mole. And the mole is not a furry little creature that gets holes in the ground in chemistry. It's the chemist counting unit. And there are 4 things about moles you should know, but this will be on the important information. First of all, 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms. 1 mole of a compound equals Avogadro's number, 6.0, oh, the 2 fell off there. The dreaded 2 virus hit this. But anyways, it should be 6.02 times 10 to the 23rd molecules. Then for an element, 1 mole of an element equals the atomic weight of the element. And for a compound, which I think is one of the most important things on that list, because I use it a lot, 1 mole of a compound equals the molecular weight in grams of that compound. And finally, the molecular weight of the compound in grams equals the sum of all atomic weights in a compound. These 4 statements or 5 statements will be given to you on important information. In the past, I asked students to memorize them, but now I'm testing your knowledge of chemistry, not your knowledge of memorization or ability to memorize. And we've gone through in class how to convert. You should know how. And we've done practice problems both in the lecture and in the lab with the practice problems. How to go from a mole of an element to atoms of the element and backward from atom of an element to mole of an element. Know how to go from mole of a compound to molecules of compound and reverse. And know how to go from moles of an element to grams of an element in reverse, and know how to go from moles of a compound to grams of a compound in reverse. This looks complex, but if you've paid attention, which I think you all have, and if you practice on your own, use your good buddy, your good friend, unit analysis. It will help you do the things I just showed you successfully and easily. Now finally, talking about mass calculations for a reaction, and that's if I were to say, if I react 35 grams of hydrogen with excess oxygen, how many grams of water do I make? And we'll go through a couple of those once I finish the review. That's going to be a 3-step process. First step, whatever you're given in grams, you convert to moles. Second step, whatever you can now convert to moles of whatever you were given to begin with, like hydrogen, you convert to moles of what you're trying to get the answer B, which in this case would have been water. And finally, once you get moles of water, you were asked grams of water is the answer you're looking for, so you convert moles of B to grams of B. And this is a 3-step. Have your attention. Special gift time, because it's almost the end of the holidays for me, and so I'm going to give you a special gift. If you see on the test a balanced chemical equation, and you're going from grams to grams, you're going to need this. I'll say it again in slow motion. If you see on the test a balanced chemical equation, and you're asked to go from grams to grams, you're going to need the 3 steps. Also, it's 10 points. And remember that the coefficients of a balanced chemical equation give you molar ratios. Therefore, what this really means is 2 moles of hydrogen, when there's no number, it's 1, react with 1 mole of oxygen to give you 2 moles of water. And that way you have the molar ratios to do step 2. The other steps, you use the previous, how to go from grams to moles and moles to grams. And that's that. Any questions about the review? How many found it helpful and would like me to do it again next test? All right, that by popular demand, I'll do that. Oh, by the way, how many of you don't want to raise your hand? Raise your hand. Not this person. All right. Again, everything you saw here is on Blackboard for you to download. I'm going to go through a couple of these now. This is also on Blackboard. And let's look at, first of all, the following chemical equation. You'll be given a balanced chemical equation. And it says, if you react 5.00 moles of ethanol, C2H6O, ethanol is the active ingredient in beer, wine, and hard liquor. And they also put it in gasoline to help your engine run better. And with an excess of oxygen, how many moles of water are produced? And as always, when I have a problem, I like to find out, what am I being asked to find? Moles of water. What are we given? Moles of ethanol. Therefore, this is all I have to start with. This is the units I want to get my answer to. I use unit analysis. Whatever I'm trying to get to goes on top. Units I want to get rid of goes underneath. Where do I get those numbers? From the balanced chemical equation. For every 1 mole of ethanol, I make 3 moles of water. And these are exact numbers, therefore they don't play a role in the final answer. And therefore, if I take 5.00 multiplied by 3 divided by 1, I get 15.0, which is 3 significant figures. And that's how you do it. Right away, this is how you do step 2 in the 3-step process. Let's look at number 4. And you're given a balanced chemical equation, and you're asked, how many grams of C3H8, that's propane, you know, the stuff in the white bottles that you use for your barbecue, how many grams of propane are needed to make 24.6 grams of carbon dioxide? And you're given the balanced chemical equation. Notice here, what are we being asked to find? Grams of propane. What are we given? Grams of CO2. So you're going from grams to grams. Immediately that should tell you it's a 3-step process. And the first step is, let me write it on the board. And what I mean by that is, A is whatever you're given initially the weight of. In this case, it's CO2. So the first step we have to do, step 1, is go from grams of CO2 to moles of CO2 and use from the important information the fact that if I have these many grams, I want to get the moles, I'll put moles on top because I know unit analysis. Grams of CO2 I don't want, I'll put that underneath. Where do I get that number? From important information. 1 mole of a compound equals its molecular weight. Therefore, 1 mole of a compound equals its molecular weight. How do you calculate the molecular weight? It's the sum of all atomic weights. Carbon dioxide, 1 carbon, 2 oxygen. Carbon has a molecular weight of, or atomic weight, 3 significant figures, 12.0. Oxygen, 16.0, 2 of them. Therefore, 2 times 16 is 32.0. Adds up to 44.0. Do the math. 3 significant, exact number, 3 significant. I get moles of CO2. And now I have to go to step 2. I now have moles of A, whatever I was given the weight of, and now I have to go to moles of what I'm trying to get my answer. In this case, propane, C3H8. And now I have moles of CO2. I want to go to moles of propane, put this on top. I want to get rid of this, put that down there in the ratio. As you know, unit analysis is your good buddy, your good friend, and has been mine for many decades. I shouldn't say that. But anyways, where do you get those numbers? From the balanced chemical equation. 1 mole of propane makes how many moles of CO2? 3. These are exact numbers, 3 significant figures. My answer is 3 significant figures. Do I want to stop now? No, because my answer should be grams, not moles of propane. So now I'll do step 3. Step 3, whatever you now calculated, moles, you'll go to grams. And how do you do that? Here's the moles I have. I want to go to grams. I'll use my good buddy, my good friend, unit analysis. Remember, I'm still trying to get the Guinness Book of World Records. I'm saying the most times, my good buddy, my good friend, in a semester, and I will do that. Whatever you're trying to get to goes on top. Whatever you're trying to get rid of goes underneath. Where do you get this number? 1 mole of a compound equals its molecular weight. And the molecular weight of propane, 3 carbons, 8 hydrogens. Each carbon is 12.0. Each hydrogen, 101 to 3 significant figures. Add this up. Remember, when you're adding, you get the same number of significant figures in your answer as the number you're adding that has the fewest number of significant figures past the decimal. So this is 1, 2, therefore round this off to 1 past the decimal, 44.1, put that in there, 3 significant, 1, there's your answer. Now, as I've mentioned in class before, I am of the mindset, I round off at each step when I'm doing a series of calculations, separate calculations. Other people believe you wait until the end. And therefore, it's possible sometimes to get 2 different answers. And notice I have or 8.22. That's if you round off at the very end. It's a slight difference, and both would be correct on the test. And that's how you do it. On test 2, like test 1, underneath your name, will say, please use proper significant figures for all calculated answers. And now we'll also say, please use all atomic masses to 3 significant figures. And let's look at the following problem. If you have a balanced chemical equation, 2 hydrogen, 1 oxygen molecule makes 2 water molecules. If you react 32.0 grams of oxygen with an excess of hydrogen, then how many grams of water are produced? Why don't you try and see if you can do this in case you don't know the atomic weights. Hydrogen is 101, oxygen, that should be just O-2, is 16.0. Have fun. If you don't have a calculator, just try and set it up. Oh, it gets too noisy out there. Always feel free to close the door. Be quiet. I have to get one of those signs like you see in the supermarket, yellow thing, wet floor. Mine will just say, be quiet. Anybody need more time? Going once? Twice? Let's do it. All right, I'm going to erase this because I need the boardroom. But on a test, you would be given the 3 steps. And let's do it. Now, the first thing I'm going to do when I see a problem is answer the following questions. What am I being asked to find, unit-wise? And the answer is, how many grams of water? What am I given? Ooh, it's the only thing. 32.0 grams of O2. Hold on, why? And I'm also given the balanced chemical equation. And remember, the coefficients tell you molar ratios. And for this one, 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. There's no way I can go directly from grams of oxygen to grams of water. Therefore, I need 3 steps. This looks like him too. And therefore, step 1. Whatever I'm given weight, I'm going to convert to moles. Why? The only relationship I have between water and oxygen is molar relationship. And that is 1 mole of oxygen makes 2 moles of water. So how do I do that? If you look on important information, you'll see I have 32.0 grams of O2. I want to get to moles of O2. I'll use unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. And where do I get those numbers? 1 mole of a compound equals its molecular weight. Molecular weight of a compound is the sum of all atomic weights. There's 2 oxygen. Each oxygen has an atomic weight to 3 significant figures of, I'll go this way, 16, that's 32.0. I cheated, I didn't have to use a calculator. And if you do the math, before I do that and pick up my calculator, which I don't need, grams of oxygen divided by grams of oxygen. Remember, anything divided by itself equals number 1. So this cancels out. I'm left with the right units. And let me do the math here. 3 significant figures. You'll get that. Now, am I done? No. I have to get the water. Now I'll do step 2, which you'll be given unimportant information. And that's, in this case, moles of A. In this case, A is oxygen, which I just calculated. I want to go to moles of B. In this case, I'm trying to get to water. And how do I do that? Well, I have only one number to work with at this point. I'll use unit analysis. Whatever I'm trying to get to goes on top. Makes your life so much nicer, and mine too, for many, many years. And whatever I'm trying to get rid of unit-wise goes underneath. And where do I get those numbers? Well, I come over to my balanced chemical equation. 2 moles of hydrogen, nope, don't need that. But 1 mole of oxygen, I surely need that, makes 2 moles of water. Now, before I pick up my calculator, do my units cancel out? Moles of water divided by moles of water become the number 1. I'm left with the right units. Someone help me out. I'll calculate that. And this would be 2.00 moles. Am I done? No. I'm trying to get to grams of water. And that means I do step number 3, which is on your important information. Whatever I'm given in moles at this point are calculated. My final answer I want in grams of water. So I'm going to go moles of B, in this case B is water, to grams of water. And how do I do that? This is the only number I now have for water. I want to get to what? Grams of water. That's my final answer. I have it set in about 2 minutes. I use my good buddy, my good friend in analysis. Anybody having nightmares hearing me say that? Oh, not. But anyways, whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of, the units go underneath. Where do I get that? If you look at important information, 1 mole of a compound equals its molecular weight. What's the molecular weight? That's on special information too. The sum of all atomic weights, and therefore I need to find out the molecular weight of water, 2 hydrogen, 1 oxygen. The atomic weight, the 3 significant figures of hydrogen, is 101. You'll see that in the periodic table. That's the number underneath the element symbol. And to oxygen, the 3 significant figures, 16.0. Do the right significant figures, which we've already done in class a couple times. You get 18.0. Before I pick up my calculator, oh, I cheated, I did. But anyways, check your units. Moles of water divided by moles of water cancel out, because anything divided by itself. And therefore I get grams of water, and I will make 36.0 grams of water. Did I do that right? Anybody calculating? Oh, it's working good today. And that's how you do it. You should know how to do it. If you're not sure, go back and look at the other practice problems. I've given you a number of them. And any questions about this? Well, in that case, let's move on to gases. Anybody happen to walk into the building today and either feel the wind or think about your breathing and you're inhaling gases? Or when you feel the wind on yourself, that's gases hitting you? Let's back up. This material will not be on test 2. It will be on test 3, which is coming up. So is Halloween. By the way, let's see. There's only 24 shopping days left till Halloween. And even though Halloween, I think, is on a Thursday, which we won't meet, the Friday afterward, I will bring in some candy. So you can all pretend to be students, and I will say, oh, trick or treat, here's your candy. By the way, I do Halloween by Dr. White's Golden Rule of Halloween, and that is, I don't give candy to people who come to my door that I wouldn't like myself. And therefore, you know how some people get the cheapest, awful candy? Not me, I give the stuff I like, which is the good stuff. You like Nestle's Crunch or Kit Kat? Whatever. All right, now I got your attention. Let's talk about gases. One of the important things, and I think I mentioned it, but let me go back and review this and do this, and that is pressure. And pressure, you use a barometer, and there's also gauges, but barometer. And this will be given to you, important information, but you should know how to use one. There's 2 ways of measuring pressure. One is millimeters of mercury. The other is torr. And torr is shortened for Torricelli, a great Italian scientist. I don't think they called it chemist back in the early mid-1600s or 1700s. but he was one who did a lot of pioneering work in gases, and therefore we honor him by using the unit for pressure of gas, torr. And 1 millimeter of torr of mercury equals 1 torr. Let me remind you, for test number 2, you will need a calculator and a writing implement and erasers. I'll have a couple extra in case you need it. I highly recommend you write in pencil, so if you change your mind, especially when you're balancing equations, you can change your mind easily. All right. If we look at the following, and the question is, 3 points each, say this was A, how many torr is 749.9 millimeters of mercury? Well, what are we being asked to find? Torr. I could have put how many millimeters, how many torr of a gas is so many, I could write it that way too. What are we given? Millimeters of mercury, and guess what? It's still time to use unit analysis. Whatever I start with, whatever I have, I'll start with. This one you don't need a calculator, but I'm just showing you how. What units am I trying to get to? And now I'll use unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. Anything divided by itself cancels out. Where do I get these numbers? 1 torr equals 1 millimeter of mercury. This is a definition. These are exact numbers. Therefore, the answer should have the same number of significant figures as what I started with, 4. And that's how you do it. Now, a more important measurement is atmospheres. And if you look at sea level, by definition, when there's no storm around, and this area right now, Chicagoland, most of it is at sea level, at normal weather conditions, the pressure is 760 millimeters of mercury. Since 1 millimeter of mercury equals 1 torr, that's also 760 torr. And by definition, we now call that 1 atmosphere, which is abbreviated by ATM. And 1 atmosphere equals 760 millimeters of mercury equals 760 torr. And this is a definition. Therefore, all these numbers are exact numbers. Again, 1 atmosphere abbreviated by ATM equals 760 millimeters of mercury equals 760 torr. For test 3, you will be given this information on that information sheet for the test, which is important information, because I'm not asking you to memorize. In the past, I'd ask students to do that, but as you know, I've changed my philosophy on how to teach chemistry, general chemistry. So if we look at the following, a couple things, do not write this down unless you want to. There are other units of pressure measurement. You can do inches of mercury like our weather forecasts are, and 29.9, don't write this down because I'll never ask on a test, is equal to 1 atmosphere. You can also measure pounds per square inch. Pounds per square inch, 14.7 psi, pounds per square inch, equals 1 atmosphere. I don't know about you, but my car tires are inflated to 35 psi, which is a little more than twice 2 atmospheres, and that's what keeps them pumped out and inflated. In case you haven't figured it, in your tires, or if you do drive yourself, whoever got you your tires, had gas in there. I think I mentioned it. So let's do some practice time. And let's look at the first one. I've done something like that already. Let's look at the second one. The second one says, how many atmospheres is 832 millimeters of mercury? And again, I'll put down how many atmospheres is what I'm trying to find. What am I given? How do I proceed? Well, I only have one number. If I can convert that in one step, what am I trying to get to units-wise? Atmospheres. What do? I use unit analysis. Whatever I'm trying to get to goes on top. Whatever units I don't want go down here. Where do I get those numbers? From the definition. 1 atmosphere equals 760 millimeters of mercury. These are both exact numbers. Therefore, I have 3 significant figures here. My answer should have 3. And now I'll pick up my calculator. I'll come over here and I'll divide 832 divided by 760. And this is what my calculator gives me. Is that the right answer? And the answer is no. Because you should round off to proper significant figures. This is 3, exact. How do you round that off to 3? I'll give you 3 seconds. We got a lot of 3s today. Time's up. That was actually more than 3. Keep the 1, keep the 0, keep the 9. 3 significant figures. Use 4 to round off. Is that 4 or less? And the answer is yes. And therefore, the answer here will be 1.09 atmospheres. And since Dr. White shares, I'll let you set up and try and do number 3. How many atmospheres is 777 torr? For those of you who came in late, don't forget, Wednesday is test 3. You'll need a calculator, as I said earlier, and some writing implement. I use pencil. And also, don't raise your hands. If you're a blue card student, please see me after class today. And remember, when you're done, look up and smile. Oh, it works. All right, looks like everybody's done. Even though not everybody's smiling, but you don't have to. It's a free country so far. And let's do this. What are we being asked to find? How many atmospheres is 770 torr? This is what we're being asked to find. This is what we're given. And therefore, I will do the following. That's what I have, and if I can convert it in one ratio, what am I trying to get to? Atmospheres. I'll use unit analysis. Whatever I'm trying to get rid of goes on top. Whatever I'm trying to get to goes on top. I think I got it backwards. And whatever I'm trying to get rid of goes underneath. Where do I get those now? Oh, look, someone was nice enough to write on the board, 1 atmosphere equals 760 millimeters of mercury equals 760 torr. Before I pick up my calculator, torr divided by torr is 1. I'm left with the right units. These are exact numbers, and therefore I'll go to my calculator. Put it in, and what's the proper number? Well, I'm back in my rut, 3 significant figures. Exact number, my answer should be 3. How do you round that off? Keep the 1, keep the 0, keep the 2. The 1 to round off is 4 or less, so this is the correct answer. Oh, let's do one more. These are fun. Hope you're enjoying it. Do the last one. How many torr is 2.1 atmospheres? All right, I think everybody's done. Let's do it. And what are we being asked to find? How many torr? What are we given? 2.1 atmospheres. And if we look at this, this is the only number we have to start with. If I can convert it in one ratio, what units am I trying to get to? Torr. Therefore, using unit analysis, whatever I'm trying to get to goes on top of the ratio, unit-wise. Whatever I'm trying to get rid of goes underneath. Where do I get those numbers? From this definition. 1 atmosphere equals 760 millimeters of mercury, also equals 760 torr. These are both exact numbers. This is 2 significant exact number. My answer should be 2 significant figures. Let's go ahead and calculate it. And this is the number I get. Let's do something which some of you might have and put it in scientific notation. Now if we look at this, and you could put it in non-scientific notation too, but most of you, we should have 2 significant figures. Keep the 1, keep the 5, the 1 to round off. is the 9. Is that 5 or higher? And the answer is yes. Therefore, I drop this, increase it by 1, and this would be 1.6 times 10 to the third torr. That's better. And that's how you do it. And that's how you go from atmospheres to torrs or millimeters of mercury, and from millimeters of mercury or torr to atmosphere. It's an important skill you'll need for working with gases. All right, can I have everybody's attention? Everybody, take a deep breath, let it out, take a deep breath, let it out. You all relax. We're going to do some math. Relax. We're actually going to do some algebra. Take a deep breath, relax. I'll show you step by step how to do it, so it's not that bad. So don't be scared by the word algebra. Oh, it's Halloween coming up. And that's what I should come dress up as an equation. That's pretty old. But anyways, think about back about early 1700s. What was happening in the world? Industrial revolution, especially in England, and because of that in the United States, elsewhere in Europe. And yes, I know my history, and I had good history, not really, but I still learned it. But what was important? Having the energy or power to do things. How did they first get energy to run the machines in the Industrial Revolution? The water wheel. You needed a river, it turned it. They had a bell, it turned machines, pulleys, and gears to make things. And then someone invented, I don't know who, but in England, the steam engine. And the steam engine uses a piston that goes in and out, moved by steam. What is steam? Water vapor. What is water vapor? Water in a gas form. And it turns out, because of the importance of that, then years later, what was also important way of energy for the Industrial Revolution, which we still use to this day, the gas engine or combustion engine. And there you have a piston and a cylinder and a gas inside. And by understanding the relationship of key parameters when gases, you could make a lot of money. Oh, I should warn you or tell you, a lot of science, especially chemistry, a driving force has always been money. If I can do this, I can make money. And when I worked at companies, that was my job, to help, and everybody else's make the company money. So there was a series of different laws. A law is something that's always true. Do not write down the English part of this. Trust me, I'm a chemist. That worked. Anyways, Boyle, a great English chemist, I think that by then they were called chemists, came up with a relationship. And the way of saying it is the volume of a sample of a gas is inversely proportional to the pressure applied to the gas if the temperature is kept constant. First of all, temperature doesn't change. And Boyle's law is the following. Get some board space here. P1 times V1 equals P2 times V2. What are those? Well, P1 whatever gas you're looking at, that's the initial pressure, what you first measure. V1 again, that same gas, whatever volume you're starting with of that gas. Next, P2 equals the final pressure. And V2 equals the final volume of that gas. And therefore, Boyle's law is P1 times V1 equal P2 times V2, where P1 is the initial pressure, V1 is the initial volume, P2 is the final pressure, and V2 is the final volume. And keeping with my philosophy, not to have you memorize things, but learn chemistry, on test 3, this is test 3 material, important information, you will be given this. In the past, I made students memorize it, you don't have to. All right, let's look at a Boyle's law problem. And let's look at a Boyle's law problem. And now I'll get to, oh, this is awful. Hold on. My first grade teacher would be happier now. And if a cylinder of gas has a pressure of 756 torr and at 4.71 L, L is liters, it's a measure of volume. Then, oh, the end fell off. Then what happens to the pressure if the volume is increased to 46.8 liters? So, first of all, if we look at this, what are we being asked to find? What happens to the pressure? And the pressure is the final pressure. So that's, we're trying to find P2. What are we given? The initial pressure, P1, equals 756 torr. The initial volume, V1, equals 4.71 liters. Next, the final volume, what happens when it's increased, is V2, 46.8 liters. And notice, all you're dealing with is pressure and volume. As soon as you see that and you're dealing with a gas, you know you need Boyle's law. And that is P1 times V1 equals P2 times V2. Now, if we look at that, what are we trying to find? P2. And how do you solve for something? In this case, P2. First get a drink of water, then look at it and say, I need that alone on one side. Now, when you have multiplication, how do you get rid of V2? Well, anything divided by itself becomes the number 1, is gone. So I can divide this side by V2. But whatever you do to one side, you have to do to both sides. So I'm going to divide this side also by V2. Anything divided by itself becomes the number 1. 1 times something is that something. So I now have P2 equals P1 times V1 over V2. I have a habit, good habit, that I don't change, and that is I'm going to switch this around. You don't have to. P2 equals P1 times V1 over V2. I took the time to figure out what these are, so now I can just plug them in. P1, P1 is 756 torr. V1, 4.71 liters. V2, 46.8 liters. And before I pick up my calculator, but you didn't think I'd sneak it in now, I'll use my good buddy, my good friend, unit analysis. And if you notice, liters divided by liters gives you the number 1. These cancel out. What units am I left with? Torr, is that a unit of pressure? And the answer is yes, so I'm in the right track. Now I'll come over to my calculator. Put in the numbers, hit enter, and this is what I get. Now, we'll say on test 3, like test 2, please use proper significant figures. And if I look at this, I have 3 significant, 3, uh-oh, he's in his rut, 3, my answer should be 3. Round that off to 3 significant figures. I'll give you 3 seconds. So clock, time's up. Keep the 7, keep the 6, keep the 0. I use 8 to round off. Is that 5 or higher? The answer is yes. Therefore, I eliminate that. I increase that by 1. And the answer here is, and I'll move it up here so you can see it, 7.61 times 10 to the first. And my units are torr. You don't have to write that down. And that's how you do Boyle's law. Remember, P1 times V1 equals P2 times V2. You will not have to memorize it, because I'll give it to you on test 3, important information. But you will have to know how to use it. And remember, the key to this is, look for what you're trying to solve for. P2. You want to get a load on one side. How do you do that? When it's multiplied times something, you divide it by what you want to get rid of. Whatever you do to one side, you have to do to the other. I did that. This cancels out. I'm left with P2. Here's my other side. I'll rewrite it, put in the number, and it's gone. I think since you're all restless, I'll let you on a whole 30 seconds early. Don't forget to bring a calculator. On Wednesday, be on time. And if you have blue card students, please see me. And John, you drop it.